Welcome back. We're going to finish up the 12G notes on series, and we just have one last example to hit. All right, so sum of a geometric series. It sounds like some kind of like mean thing. Sum of a geometric series, right? Yeah, well, maybe not. So anyway, here's the sum of a geometric series. It's S of n equals u sub 1 all times r to the nth power minus 1, and that whole thing all over r minus 1. Okay? And actually, something that's been left off of this formula here is where, let's see, there it is, where r cannot equal 1. Okay, and if you can come into class tomorrow and tell me why r can't equal 1, you can get a little bit extra credit. Okay, so I'm not going to tell you here. You're going to have to figure that out, and then we'll talk about it tomorrow in class. All right, so we have this here. S of n stands for the sum of the series, just like on the arithmetic. U sub 1 is the first term. R is the multiplier, just like in the geometric sequence. And then n is the number of terms. So those are all the things that you're going to need to know in order to solve a problem, to find the sum of a geometric series. Okay? So let's find the sum of 2 plus 6 plus 18 plus 54 all the way up to 12 terms. Okay? Now, this one here, you should be able to hopefully quickly recognize that this is not an arithmetic series, because you do have to go plus 4 to get to 6, and then you can't add 4. 6 plus 4 does not give us 18, so that means this is not arithmetic. That means it's got to be geometric. So then you got to figure out, what do we got to multiply? 2 times what gives us 6? 3. 6 times 3 gives us 18. 18 times 3 gives us 54, so forth and so on. Okay, so that shows that it's a geometric series. Okay, so we need to know, in order to find S of n, we need to know u sub 1, r, and n. So we need u sub 1, r, and n. So u sub 1, first term, and this one is 2, right? R, the rate, the multiplier, is 3, and the number of terms is 12. So we have everything that we need to know. So now we can just plug that into this formula, and away we go. All right, so S of n is going to equal, I'm just going to copy it down for good measure, r sub n minus 1 all over r minus 1. So S of n, u sub 1 is 2, r is 3, n is 12, so 3 to the 12th, minus 1 all over r, which is 3, minus 1. Okay? So S of n equals, let's see, we're just about to finish. We should have someone finish this up for us. How about this fluffy little teddy bear? All right, let's go with that. All right, so let's simplify this as much as we can. 2 times 3 to the 12th, can't really do a whole bunch with that, right? We got to actually calculate that out. Minus 1 all over 2, right? So this is kind of nice because these 2's will just reduce each other down to 1. So really our S of n is just 3 to the 12th minus 1. I do not know what 3 to the 12th is, so let's figure it out on our calculator. 3 to the 12th power gives us a big number, 531,441. Okay, so then we actually got to subtract 1 from that, so we get 5,000. Gosh, I'm having a hard time. 531,440 is going to be our answer. Okay, so S of n is going to equal, let's see, we had 5,000, goodness sakes, 531,440. I think I've only done that what, 3 times now? So we have to do this. 531,441 minus 1, so S of n is just 531,440. That is the sum of this sequence to 12 terms. All right? Now, you should be able to say that I can find series and sums of series given several terms and vice versa. All right? If you have any questions, please ask. Thanks.